Let's dive into the critical topic of head temperature management, focusing on the D15 head temperature during continuous pumping, cool down, timing, and effective cooling methods. Maintaining the right temperature is crucial for the longevity and optimal performance of the equipment. First, let's consider D15 head temperature during continuous pumping. The D15 head, like any mechanical component, generates heat as it operates. This heat comes from friction, the movement of internal parts, and the work being performed. During continuous pumping, this heat builds up, and if not managed, can lead to overheating. Overheating can cause several problems. It can degrade seals and other components, leading to leaks or failure. It can also affect the fluid being pumped, potentially altering its properties or causing it to break down. Monitoring the D15 head temperature during continuous pumping is therefore paramount. Regular checks, possibly using built-in sensors or external temperature probes, can help to identify any unusual temperature increases. Any deviation from the normal operating temperature range should be investigated promptly. Next, let's talk about cool-down timing. When the pumping operation is stopped, the D15 head's temperature will start to drop. However, the rate at which it cools down is important. Rapid cooling can also be detrimental, potentially causing thermal stress and damage to the components. Cool-down timing should be controlled and managed. If the D15 head is cooled down too quickly, it can cause internal stresses, leading to cracks or other damage. A gradual, controlled cool-down period is usually recommended. The length of this cool-down period will depend on factors such as the initial operating temperature, the ambient temperature, and the specific design of the D15 head. The manufacturer's guidelines should always be followed to ensure proper cool-down procedures are in place. Finally, let's explore cooling methods. Several methods can be employed to manage the D15 head's temperature. The most common method involves using a cooling system. This might involve circulating coolant, such as water, or a specialized cooling fluid, through the head to absorb and dissipate heat. The cooling system may be air-cooled or liquid-cooled. Air cooling involves using fans to blow air over the head, while liquid cooling uses a coolant circulating through the head and then through a heat exchanger. Another method is to use heat sinks, which are designed to draw heat away from the components and dissipate it into the surrounding environment. The choice of cooling method will depend on the specific application and the operating conditions of the D15 head. Maintenance is critical to ensure the cooling method is effective. Regular checks should be performed to ensure the cooling system is operating correctly, that coolant levels are maintained, and that there are no leaks or blockages. In summary, managing the D15 head temperature is critical for reliable and efficient operation. Monitoring the temperature during continuous pumping, adhering to appropriate cool-down, timing, and employing effective cooling methods are all essential to preventing overheating and ensuring the longevity of the equipment. Always consult the manufacturer's guidelines for the specific D15 head model to ensure proper temperature management practices are implemented.